hackers inserted malicious code into the update of software platform. It's called Orion. So we call it is a supply chain attack. Why? Because in the I'm gonna briefly explain that. The first, the Russian attributed the hackers compromise code in a software data of the update of the solar. So we call the Orion, and then they put it in. So they inserted the malicious code into the B9 program. We call the supply chain attack. And then every user who installed the software automatically updated it, and then the users deploy and install the compromised Solar in the app through the software updates, and the malicious code executed automatically. So, and then malicious data becomes out to C2 infra to get the commands additional payload. So, which means that as long as adversary compromises the server of the building, software, and also um, the software also let's see the software also they automatically updated it automatic malicious payload send it to the B9 users, and the users automatically install, and automatically the malicious code is executed. So this is a solar winds breaches, solar winds security problems, and it's actually this is Russia, and these Russia hackers targeted this company, and then the United States government also use this kind of app as well. So that's why we believe that this attack is conducted against the United States government. So and then the first in December 8, 2020, and then before then nobody knows that. However, the security company FireEye, I'm not sure how many people familiar with this company, and announced that they found that the FireEye was believed to be one of the target, the SVR, the Russia Foreign Intelligence Services, and then the FireEye is the first report to this breach, the security issue, this attack to government, and then NSA realized that at the time. After then, realized that Russia conducted the kind of attack, so against the United States government. So this is a really big the security issue, and then also we call the supply chain attack. So because this is the solar means to have a supply chain right now, right? So because this is the distributors, the solar is distributors, and then automatically the program is delivered to the software users, right? So that's why as long as the attackers compromise the software, and by inserting a malicious code into the B9 program, and this program package automatically send it to the B9 users, and the malicious code will be executed automatically. So this is what we call the supply chain attack. This is the strong one of the strong the one of the strongest attack in the world. Okay, and then let's see. All right, this is we have seen the solar winds attack, and this is one of the strongest attack. Okay, today so recap the permissions and then UID, and then also we're gonna cover what kind of security services to set UID before, right? We're gonna cover so what kind of service attack surfaces of set UID programs. As we covered last week, so operating system provides abstraction of complex hardware and protects access to shared resource and communication and security, right? So as long as you have operating system, you don't care about what kind of hardware being used in your computer, like a CPU and Intel, ARM, whatever, and the memory is a 16 or 32, and the USB and the GPU and the storage, whatever. No matter what the device is attached to your computers, as long as you have operating systems, so you don't your program and you don't care about too much about the hardware. And then permission bits is that there are three groups: the users group and then others, and then RXX. It's a simply this is a simply and then this is represented in integers, right? For example, 755, and which means that you just can write executable. However, group cannot write, and then also others cannot write. And the user ID is that number is assigned the user Linux to each user's system. So because the multiple users can be used in the same time in a Linux machine, that's why the Linux assign the unique numbers to users. So and then special users root is can do can do everything he can do in the Linux machines. So and then root user's ID is 0. And then so for the need for privileges, then the password dilemmas and then permissions, the shadow. So you know what it is. So right. So okay. And then I'm gonna publish the quiz. Let's go to. I'm gonna make it publish the quiz, and then let's have a quiz. Let's see. Okay, temporary. This is different from directory giving the privilege like a I'm not sure how many people have used the sudo before. And then sudo, if you run the sudo give you privilege, root privilege after you executed the file. However, set UI is different. Sudo is give you not permanent but give you long time the root privilege. However, set UID gives you very temporary the root privilege. So and then this is a set UID and then provide you root privilege with the restricted behaviors. And also this is unsafe to turn around a program into the same UID. For example, shell and the VI, and the VI and the shell enables the users adversary run the command or the binary. That is really unsafe to enable those SendUID, enable those shell and VI um, enable send UID for those binaries. So the send UID and the sudo, what's the difference between sudo and the send UID is that the first thing is the sudo. The first thing is ask for the user your password and compare to the shadow, right? Previously we explained that your password is stored in the shadow, and then as long as your password is correctly prompted, you insert and you put in, and then so and the check if username in or group in the sudoers in the file. As long as you are belong to the sudoers, and you can get the root privilege shell. So this is a kind of different. So if you look at the if you ls the sudo, you can see that you can see that this is S is a magic bit. This is a pseudo the binary. So you can see that pseudo is S set UID, the set UID the binary. So that's why um, so pseudo is a set UID binary. This is kind of different. So and then as long as when you execute sudo, you can get a privilege, and then because the sudo has a send UI binary. So please don't complain like a quiz in the class. Okay, please come to my office hour or send the email. So don't disrupt this class, and don't disrupt other people who listening to the class. Okay. So everybody complains. So the quiz is not a big deal. Okay. All right. So, and then the attack surfaces, we can see the attack surfaces of same UI the program. So, there's a three types of, attack surfaces of the same UI. The first thing, user input. As you can see that, same UI that can be used by adversary. And then also second thing is a system input can be controlled by users. And then environment variable. So we're gonna look at each of them, and then I'm gonna give you example and see how adversary exploit and then exploit the same UID, the vulnerability of same UID. So that's why you always think about how adversary exploit your program with the same UID. Okay. Okay, the tech beer, the user's input, and then, for example, we believe that all the users are benign. However, the users can be adversary, right? So, which means that, previously we have seen the bulk overflow and then format string the vulnerability, which is the one of the problem is that users can be adversary, and then the users can put malicious code and then exploit, this kind of vulnerabilities by passing the inputs into the your program. So as you know, buffer overflow and then format the string the vulnerabilities. So one of the examples is the change shell. The change shell is that the set UI the program is available to change the default shell program. The shell program is stored in the etc in the password file, right? So as you can see that, recall that the password, user ID, and then also there is some informations, and then the last of the string, there is a default shell, the shell. Okay, and then you can see, but however, attackers could create a new root account. So for example, here the change shell, you can type with the option the s, and then by s, and then the shell, and then automatically the last of the information, so default in the shell can be changed to being the G shell. So however, so adversary can exploit this vulnerability. How can do that? Is that, the, like, for example, the G shell and the new line and the root or something like that, which means that if your change shell doesn't sanitize like input by inserted by the adversary, and then adversary can insert a new line the next of your ID. So for example, if you type like a bin G8 and G shell in the line, and then and the new lines, and new lines, and then the new line started here, and then root and then something information. If you inserted like those informations, the root and something like that is inserted, and as long as root here, and then you can create a new root account. So this is the one of the user input example. And then another the example is the adversary use race conditions. So race conditions. Race conditions. Can anyone recall what the race condition is?
When multiple programs running in concurrency try to access the same data and therefore mess it up.
Mm-hmm. Yes, exactly. So the race condition is that it happens when the multiple process access the same time, and then manipulate the same data currently. As you know, one instructions can be executed by the CPU, which means that others programs be paused while other instructions be executed, right? So while the executions are being waiting, waited, and then adversary inserted manipulated some data, something like that. So order of execution depend on a particular order, and then if a privileged program has a race conditions, the attacker may able to affect the output of privileged program by putting the influence of the uncontrollable event. So here is that I'm going to give you example. This is a race condition vulnerabilities. So here is code. So this is further free information, and then this is a root on the set UID program, and effect user ID. UID is root, and the real user ID is seed. Seed is just one of the example, and then like for example, COC SC 366 user ID, something like that. And then code is the above code write a file in the temporary directory, like a temporary directory. They're gonna check the accessible or not, right? The root 2 can write any file. The program ensures that we just have permission to write a target file. So this is a permission. So write okay means that the write okay means that the program checks that if you have a privilege to write this file in the temporary X, okay, and then if you have access. So if you have access, access calls to check if your user ID have right access to temporary X, temp and slash and X file in the temp directory. And after checks, this file is open for writing here, the check and the open and the writing. And then open checks the effective user ID, which is 0, hence the file is open. So you know what I'm saying? So here. So so anyone guess what kind of security problems here? So this is a very simple code.
Multiple people could write to tempx.
Multiple, yes, but more specifically. Okay, I'm gonna give you more hint. So okay, so our goal is to write protect the file like a password. Okay, this is a file is protect the file, and then also, but to achieve this goal, we need to make password as our target without changing the file in the program. So this is we can utilize the symbolic link to help us achieve it. So this is a special kind of a file that point to another file. This is, I'm not sure how many familiar with the symbolic link. So I think who have taken the operating system class, you know what the symbolic link, and but the people doesn't people do not take did not take the operating system class before. You're not familiar with the symbolic link. The symbolic link is very soft link, and if you created this file and they link to another file, this is very special. Is a pointer. In the pointer, like a C language is like a pointer. So this is also information is point to another file. So how we can, this is a hint. So we can hint is we're gonna use a simple link, and then our goal is to write a protection file like a password. So how we can exploit these vulnerabilities? What is vulnerability sound, and how we can exploit these race conditions vulnerabilities? Anyone can guess? All right, so if I'm gonna give you answers, so first is that in a created regular file X inside a temp, right? So let's go back to code, and if before executed this line, create a regular file X inside the temporary the directory, right? And then here's code, and the first line is passed because you have permissions, right? This X file in temporary directory, right? Makes sense? And then change the temporary to the symbol link to the point the etc the password. It is a password, after this pass while the instructions are being executed this line, and it while these instructions are being waiting to be executed, adversary change the file x to the symbol link, and that is pointed to the password is protected file, and then open check the EUID, which is root, right? And then as you assume that effective user ID is the root, and then open the and then we can open the password file for write. Okay, that doesn't make sense. So as a program runs millions of instructions per second, the windows between the time to check and the time to use last for every short period of time, making impossible change the symbol link. So which means that if a change is too early before execute be before exits this line, the first line be executed. If you change this file to symbol link file and it fail. However, and also if you change the file of file X to the symbol link after this line, you fail as well. So it's really hard. It's really challenging for adversary um, to defeat exploit vulnerability. So, however, I want to show you that it's possible using exploring the race condition vulnerabilities. So here is the more detail. This is a diagram. It helps you understand easily understand it. So the first created X file at the beginning before the program executed, and they point to the attacker on the file. So this is a X is a writable to the adversary, right? And then as long as immediately after the access is passed, the adversary changed X point to the executed password. This is a protected file, so which means that context switch, and then when they come back to the privileged program, and then the program trying to the privileged program is trying to open this file and then write the password or execute the password. The password uh, password in the etc the directory. So right. So to win the risk conditions, we needed to process run the vulnerable program in the loop, right? The loop, and then keep doing until it's success, and then also run the program. So let's just see if we fail, and then run the privileged program or take a program is until the it's a success. This attack is success, right? Is this is a simple just a condition. Okay, so here's another conditions example. So this is another code. This is also saying UI the program runs with the root privilege, and then first thing is check if the file exists, right? Check the file existence and the file, and then if the file doesn't exist, and then they can open the file and they create it. So if not open the system call is invoked, the file does not exist, new file created with a provider name, right? And then, however, there's a window between the check, right? Check and the use open file. There's a window, right? Adversary can exploit this window and then insert change this file, right? So the file is already exist and an opens system call will not fail, right? Will not fail, and they will open the file for writing. So we can use the window adversary. We are adversary. You can use the window between check and then use the use and the point to the file to exist the password, and then eventually we can write it. So we have a window we can exploit. We can change the X file, file. We can change the file to a symbol link that is points us to the password is that is a protected file, and then we can open this file and then we can write a file. We can adversary exploit this window. So remember that. So race condition is that. So race condition is that this adversary can exploit this vulnerability, the window between the checking and the writing. Okay, this is a race condition vulnerabilities. As I said before, so we have seen user input, and then also another attack is environment available. So adversary can conduct the attack via environment variable. So environment variable is that that can be set by users before running programs. So how many people familiar with the environmental variable? So I think some of them have some of you already have taken operating system. You know what the you know what the variable is, right? So however, the people who not have taken the operating system classes before, you're not familiar with the environment, the variable. So the environment, I'm gonna briefly explain what the environment variable. For example, if you type a command and then the command, and the Linux machine is trying to find where your command you type in located in the Linux machine. So which means that uh, which means that, and then for example, this is a path environment variable. This is a where if you type the the command, for example, the cat or whatever, and then they're trying to locate it by where the binary it is. So and then the uses by shell command is a program to locate a command if users do not provide the full path to the command. Like for example, cat, and the cat of a certain file, and then they already know that where is the cat is because the path is the cat is located in the bin file. That's why it automatically located, and then the command and the cat is executed. However, the which means that if you the system call is invoked and then first call the shell first, which means that the path environment is also executed as well. So for example, the system ls, and then the bin shell use the path or the path and the environment and the variable tool to locate ls, and then I'll take her manipulate the path variable and the control how the ls command is found. Okay, so how we can the system call and with the ls and then can be exploited. So let's take a look at how adverse can exploit. All right, so the first thing is the capability leaking. So let's see. Okay, so first case is this capability leaking, and in some cases, the previous program downgrade themselves during executions, like for example, soup program, and then this is a privilege set UID. I'm going to briefly explain what's the soup program. So the soup program is privilege set UID program. I'll also one user switch another one, and they say user one to the say user two. And then, for example, you want to switch to another user, so you can use the soup, the type of user one and the user two. You can switch to one user and user two. And the program starts the effective UID and the root and the rear user ID as root user one. So after password verifications, both the UID and EUID and your UID become user two, so via the privilege downgrading. Such program lead to capability leaking. So that's why program, and sometimes the program may not clean a privilege capability before downgrading. So here's things. So the attack via capability leaking. So here example, I'm gonna give you 2 minutes to read this code and then what kind of vulnerability in this code. And then anyone who know the answer, please raise a hand and then answer. Say what the vulnerability is. Okay, the hint is that it's not related to race conditions, something like that. It's not race conditions problem. So what is the okay? So Noah asked the questions that what capability leaking is actually is. So I'm gonna briefly explain after read this code. So this is the example code, and they guess what the real vulnerability, and then after this you know that. you know what the capability leaking. So that's why I'm going to give you this code and then see what the code is and then what vulnerability is code. And then after this, you realize that what the capability leaking is. This is very simple, very simple, very simple, the very simple answer. Okay, so I'm going to briefly briefly explain what the code is, and then I'm going to ask a question again. So the first line is that the etc the zz file in the etc is only writable by root. For example, etc zzz, and then first open this file, and then the file descriptor is created, right? Of course, this is open file, and then read and write the permissions and append it, and then open file, and then is open file trying to fd is the fd this descriptor is printed here, and then and then the privilege downgrade. Okay, and then invoke the shell program to behavior restrictions the program liquidator. Like for example, here it execute the shell, and then so the parameters is 0. So here's code. So what's the problems here? What's the problem? So I'm gonna briefly explain what the code is, right? So first, this is a send UI program, and then you can open this file. Okay, this is only writable by the root, and then they check if the file is open. Okay, and then print fd is a tag, and then they downgrade the UID because this is a send UID. Of course, they're gonna downgrade. Get UID is the current they this is which means their previous downgrade. So send UID to okay, and then they executed the shell code. What's the problems of the code? Can anyone guess?
Is it the set get line?
Is the which one? Which line?
Set UID, get UID?
Not true. So it's not a vulnerability. There's no vulnerabilities. Not really.
Does it have to do with how you're opening like a file that's only writable by root and then doing the get set?
You mean these parameters here?
I guess.
Yeah, not really. So I'm gonna give you 30 seconds, and then I'm gonna give you answers. This is a very simple, right? So remember that I'm gonna another hint. So in the Linux in the C code, when you like for example, what are you supposed to do after malloc or memory? What are you supposed to do? Yes, exactly. So Andrew, like Andrew said, file the descriptor is not closed. So here, so open is they open here, right? It's in the C code. You're supposed to close every file descriptors that is opened before, right? For example, as I said before, for example, you allocate a memory in the heap, you must, free the memory that are located in the heap by using the free, right? And also C code, you also, when you open this file, you should close the file as well. So which means that the programmer, the file this coder of this program forgot the forgot the closing the file descriptors. So which means that the program is forgot to close the file, so the file descriptor is still valid. So which means that I'm going to give you an example. This is what we call the capability leaking. So you're supposed to close the file descriptors, and then but if you didn't, which lead to another capability leaking. So here is the example. The code name is cap leak. This is a code name is a cap leak, and then as you know, the change owner of this file to root, right? And then also set enable send UID. Send UID program is 4775. You can see that there's a special character, special S here, means that this is a send UID program. Okay, and then if you type cat etc zzz, and then there is a bbb contained in the zzz file, right? And then if you're trying to echo aaa to the etc, which means that this command line means that the aaa be written in the zzz. However, zzz permission denied cannot write the file. As you can see that zzz is only writable by the root, right? And then there's permission denied. However, when I run this code and then the ftd is, ft is the number of the fd is printed here. So as for your information, the Linux system, the file descriptor is integers. When you open this file, fd is integers, while -1 means that this file opening the file is just failed. Otherwise, positive number is returned. So when you run this code, ft is a 3, and then which means that ft is the descriptor is number 3, and then which means that you're supposed to close this file. However, you forgot to close the file, and the file still open right now. And then if you echo ccc, and then this is a and then this is a they gonna use the file descriptors, and then they're gonna write the ccc append you're gonna try to append the ccc to the number 3 of the file descriptors, and then exit, and you can see that file there is a ccc appended. So we call that is a capabilities leaking. Okay, so the thing is that when you open the file, you always remember that the files you always close the file. So, and then also you allocate a memory in the heap. You always free the memory that is allocated in the heap, right? This is a C code, so that's why many people make a mistake. So right now, modern languages automatically closes file, automatically delocated, free the memory that you located heap memory. But the C language is invented in the very 50 years ago. That's why you did manually. So how to fix this program? So you should close the file and then destroy the file descriptors before downgrading preplaces. So as I said here, so before that, you should close this file description, something like that. All right, so this is what we call the capability leaking. And then so another thing is the invoking program. So invoking program is the external command from inside program. For example, so here the system call and the execute CVE. This is the system call. In the functions inside, and inside your program, you will run another program. You run on the program which is called the invoking program. So invoking program is the invoking external program from the inside of your program. And now external program is chosen by send UI program. You're just not supposed to provide the command, or it is not secure. So users often provide input data, which means that you remember that users can be adversary, and then your adversary exploits vulnerabilities. If the command is not invoked properly, users input may be turned into program command line. This is very dangerous, right? So I'm gonna give you example. So the one of the easiest way invoke external command is use the system for the system call functions, system call functions. So here is the code, and then here is then, oops, the program is supposed to run the cat, right? The program. So here's the example. Here's the example code and the OK string, the bean cat. This is this is the path of the cat, and then argument is less than the number of argument is also 0. The path, okay, and then the command is malloc, and then string the cat. String length is the cat, and then string length is the, you know, the first argument in the +2, and then the command they're gonna this is the s string to f is to send the format to the output to the string the pointed by this command. So this command is a string, and it is allocated the heap, and then this string is appended. The string can have the cat, and then the argument is passed by inserted by the users. So and the commanded generated, and the system call, and the system and they call this external command. So this is a root. Remember that, assume that this is a root on the set UI program. So the program can view all the files, but it cannot write any file. This is assumptions. The question is that how we can use the program run other command. So with root privilege. So how we can exploit this code?
You could pass as the argument like a semicolon.
Oh yes, exactly.
Your
So
command.
yeah, exactly. So like Hunter said, you know, so here is that we can call the root shell with the input. So like for example, AA and then semicolon. Semicolon is that although you can insert it on another command line and then insert the bin shell. Shell is as long as you got the shell, you can you got it. You got all the computers with the, if you got the executed shell, and then whatever you can do in the system as long as you have a executed shell with a root privilege. So every time you can see the hacking cases, you can see that most the adversary trying to run the executed shell code. So with the root privilege. So and then you can read the edit file, you can read all the file, you can delete the file. So whatever you can do. So here's the example is that, so this is we call the cat all, and then you can see that change the owner and the permissions, and it said enable the set new ID, and then cat all, you can see the set shadow file, of course, because this is the set new ID program, and then when you're trying to read the shellcode in shadow, you can read it. So right. However, as Hunter says, when they adversary can utilize the semicolon, and they put in the semicolon and the shell code here, the shell the execute shell the command here. So and then the cat here is that call the function AA, and that cat the cat here, right? The cat and then AA that doesn't exist in the file. However, the bin shell is being existed, and then shell can be executed. And then here is that the shell is executed, and if you type, and you can see the effective value is 0, 0. Like as long as you have a shell code, can now you can now compromise the system. All right, so invoke a program safety is that, so what are you supposed to do, because we have seen the system call is unsafe, because the system call, as I said before, the system call the first invoke share program, that's why this is unsafe, and it doesn't check the parameters, something like that. However, the execute is ve is the system call function is that, and then this code and the data is clearly separated. So code and the program and the command the data is separate. There's no way the user's data become the code. So that's why command name provided here by program, and the input data are provided users. They're separated. So that's why you are recommended to use these functions. So if we change this code, and then we could run this no file just the directory, and the text fail because the data being treated as data is not code. So that's why this code is not executed. The another additional consideration is some functionality is X. The family behave similar to the XCV, but the may not saved. Um, so as you said, the path environment variable can be attacked. For example, I'm going to briefly explain. I think I forgot to explain what the vulnerability, the path environment, how to adversely exploit the path environment variable, which is that, for example, as long as adversary have a privilege to modify the path environment, and then, for example, they're gonna put their malicious the path into the path environment variable, and then when do they run the code, they automatically locate the malicious code, and the malicious code is executed. This is a path environment attack, and that's why this is also duplicate action the shell. However, this function can be attacked using the path environment variable tag, the vulnerabilities. So, and then the invoking external programming language also, because the PHP and Perl, they have all the languages have this kind of functions. So, however, this function also the PHP, Python, all the functions that has a system call. However, there's a two type of system call. First thing is unsafe one, very easy to use, but this is unsafe. And the other thing is a safe to use, is harder to use, but this is a very safe. So you should always read the API, the documentation, and see which one is safe or unsafe. So something like that. And the principal isolation is that don't mix the code and the data, and they'll take a duty variation this principle, and then the system mix the code and the data, and then also the cross-site scripting and SQL injection, buffer overflow tag, and then the SQL injection is that we're gonna cover SQL injection and the cross-site script in a 2 weeks later, in 2 weeks. So you're gonna learn what the SQL injection and the cross-site script. So by the way, the attacker duty variation is principle. Don't mix the code and the data. So this is the principal isolations, and then also the another principle is that principle will list the privilege, and the privilege program should be given power, which is require the performance of the task. And then the disable privilege, the temporary or permanent whatever, when the privilege doesn't need those. So don't give the program any privilege if you don't need it. So because even though this is very temporary, we have seen that race conditions, the vulnerability, adversary can exploit very short window vulnerabilities, right? Vulnerabilities. So that's why if you think your program doesn't need a privilege, don't enable privilege for your program. And then, so in the Linux, in the set UID and the set EUID and UID can be used to disable discard privilege. And then the different operating system, different way to that. So we cover the Linux machines though. So last part is the virtual machine. So this is the last part. So what's the virtual machine is that, so we have seen the operating system, right? So we have seen, but the virtual machine being used a lot right now. So as you know, the first program assignments also, I provide the virtual machines for your first program assignments, right? For Stack Overflow. So for efficient, isolated duplicate of your computer machines, and then this is another machines running on your computer. So you're gonna have another operating system on your Windows or Mac or Linux, and then which means that they're gonna provide isolated environment where you can play with. For example, in the program assignment 1, I provide environment where you can play the way the Stack Overflow, and then I provide a separate operating system. So, however, if I ask you to play with the buffer overflow the attack on your laptop, you may disable your security preventions, and which can be exploited by adversary. That's why nobody wants to disable your protection on your laptop. So that's why we provide we provide the virtual machines, and you can play with this kind of vulnerabilities. Also, second programming assignments will be the web security, and then you're gonna conduct SQL injections and then cross-site scraping. So, and then also I'm gonna provide the virtual machines and where we can play or conduct a lot kind of those attacks. So, all right, and then that's why we are gonna use the virtual machines, and then also and then you can simulate hardware. For example, I'm not sure how many people have been experienced in the programming, Android programming, or iOS. And then because as long as you don't have, but if you don't have a hardware like Android phone, physical Android phone. However, you have a simulators and emulators and simulators, and you can run your test code on your program on the simulators and emulators to see your code is properly working or not. Okay, that's why the virtual machine is simulating the hardware as well, and also run operating system to simulate hardware. So it's called a guest OS. And then you can see that guest OS isolate, as I said before, the program assignment, guest OS isolated. You can see the real hardware. So virtual machine. The which means that if we log in the virtual machine I provide you with for your program assignment, you cannot see the real hardware. You don't know what is the real hardware is outside of your real machines, outside of no outside of virtual machines. So which means that you cannot see that real hardware. You cannot see the real hardware of your laptop, which is outside of a virtual machine. And then you can see that virtual machines interfaces. You can program this machines interfaces are placed here, and then physical machines interfaces here. And then the system virtual machines are VirtualBox and VM machines, Hyper-V. And there's a two type of virtual machines. And then I briefly explain later though. And then the virtual machines, and then provide the isolated environment for users, and then users can can execute the binaries on virtual machines as well. Then another thing is then hypervisor. Hypervisor is the essentially program that runs the virtual machines and then prevents the guest OS with collected hardware. So the translated interactions of virtual hardware interaction is a bare metal. So you can see that there's a two type of the hypervisor. The first is the type 1 and the type 2. And the first thing is that the type 1 is that run directly on hardware, the gen, and then gen, and the type 2 is that conventional operating system virtual machines and the VMware and the VirtualBox, and which is that most people have used the type 2, and the program assignments also type 2, right? And the virtual machine I provide for the program assignments is also type 2. However, type 1 is a gen. So if you have a chance to look at the cloud system, and the cloud system have a in the cloud system, there is a one physical server, so where there's a multiple, operating systems running. So which means that they use the gen and then running the multiple operating system, and each operating system provided to users, and users can use each operating systems, even though they're sharing the hardwares, but they feel that they cannot see outside of the virtual machine. So which means that there's a two users, user A and user 2. They use the different operating systems and using the gen, but they're using same shared hardware. However, user 1 cannot see the user 2. So which means that, so anyway, so type 1 is that if you purchase the server and if you install gen, you can run the operating system, the virtual operating system on the hardware using the gen. So there's no Linux on the between the the virtual machine and the hardware, which means the gen is a very minimize hypervisors that it can enable us to running multiple operating system. So if we're Amazon, the AWS, and then Cloudflare, and then whatever all the or whatever the cloud system, they utilize the gen to run this kind of operating system, multiple operating system, because the hardware kind of expensive. That's why hardware also cannot be utilized by a single person. That's why they purchase expensive hardware, and then they run multiple, they're gonna install the multiple operating system, and they sell this each operating system to other each people. So that's why this one type 1, type 2. And you can see that type 1 is a native bare metal. The bare metal is this hypervisor is the hypervisor is located between operating system that is can be Linux, so you can play it with, where you can play with, and then hardware is here, and that is a type 1, for example, Zen. However, type 2 is the operating system, for example, Linux. You wanna, for like program assignments that I provided for. And then hypervisor here, like a virtual box, and the operating systems here, like for example, your Linux, Windows, and the Mac, whatever, and then you install the virtual machine, and the virtual machine placed here, and then operating system, the another Linux machine is here. This is type 2, is hosted in the native. So security of applications that that give us a disposable environment, of course. So if you want to run the security code, if you run the malware code, you don't want to run the malware code in your bare metal bare metal program, right? Bare metal your hardware, so in your laptop. So that's why you install, you may utilize a virtual machines that you make an environment. For example, malware is only running for Windows 7, and but if you're in Windows 10, so you can install Windows 7 in the as a virtual machine, so you can play with the malware in the Windows 7. So such like that. So honeypot and the malware analysis, they use these virtual machines. So honeypot is that, like a honeypot is that, so you want to see how many, like a honeypot is that there is kind of devices or solvers where the adversary can trying to exploit. So you can launch the solver with the vulnerabilities and see how many people, and then how adversary exploit this vulnerability. This is a honeypot. So adversary doesn't know this is a kind of this is a really honeypot or something like that. That's why we security researchers can collect it, can get the informations of how adversary trying to exploit vulnerabilities. So anyway, so we don't have enough time, but I'm going to quickly over these virtual machines, and then the shared resource present a risk to integrity the credentiality, and the virtual machine remove the risk. Something like that. But virtual machine cannot see outside of the virtual machine. That's why the integrity confidential, the risk to integrity confidential is prevented. And then also cloud system, I just said, if you use Cloudflare and AWS, and then they use to hypervisor the type 1 hypervisors, and then you can see that you can use that, and that there's a lot of the VMware, and then Google, Amazon AWS, and digital oceans, and then they provide the provisions. And then another thing is that the Docker. I'm not sure how many people are familiar with the Docker. Docker is kind of a type of a Docker, another type of virtualized. This is a very minimized virtualization. So the containers are single process, because previously container, like the virtual machine is a whole operating system. However, this container is a single process paired down to virtual machines. So if I need for example, Apache server, and then container only have Apache server. So originally is running the Linux, Unix, or something like that, but right now is you can run in the Dockers on the Windows as well. So major container platforms, so Docker, LXC, Linux containers, or Docker is one of the top popular the containers, and then Docker is really fascinating though. So anyways, there's this kind of security issue. The container is supposed to isolate the software from outside the world, of course, and then but they're needed to get the external resource if we do not do anything usable. Container not export the ports, the network port, the network interface, storage disk, and in the Docker they call the volumes. So all of these exposed containers, the same issues the virtual machine in the operating system has. And there's a continuous breakout, and then there is a vulnerabilities, and then a breaking out of Docker via run C. So this is a very interesting article. So if you have a chance, you can read these articles and see how adversary break down the containers, the Docker. Okay, that's it. So I'm sorry for overtime, and see you on Thursday. And then on Thursday we're gonna cover the networks 101, and then and then okay, see you on Thursday.
Thank you.
Thank you.